Hello, in this lecture we'll answer two questions. In the first question, we find out the length of this tangent MF that is equal to x. And in the second question, we find out the length of this tangent AP that is also equal to x. So we start with the first question. In the drawing, we have three identical circles. And we have this big tangent that is tangent to this circle at point A. The big tangent is tangent to the middle circle at point B. And it is tangent to this circle at point C. In addition, we have this is a convex point M. From this convex point M, we have tangent AMD. It is tangent to this circle at point D. And the length of this tangent MD is 5 units. In addition, we have also tangent ME that is tangent to this circle at point E. Point E is the point of tendency of tangent ME with this circle. And the length of this tangent ME is 7 units. And finally, from the same convex point F, we have tangent MF that is equals to x. And tangent MF is tangent to this circle at point F. And our mission is to find out the length of this tangent MF that is equal to x. So to find out the value of x. Okay. So first of all, we define the center of this circle. This point is point P. We define the center of this middle circle. This point is Q. And we define the center of this circle. This point is point S. In the next step, we join points P and D together by straight line. PD is of course the radius of this circle, and we find the radius of this circle SR. And because of the fact that those three circles are identical, all the radius of those circles will be also R. So here we have the radius PD of this circle is going to point D, that is the point of tendency of tangent MD with this circle. And whenever your radius is 1 to the point of tendency, then tangent MD will be perpendicular to the radius PD. If MD is perpendicular to PD, it means that this angle equals to 90 degrees according to rule 1. Likewise, we join points Q and E together by straight line. QE is of course the radius of this circle is equals to R. And because of the fact that the radius QE is 1 to point E, that is the point of tendency of tangent ME with this circle. And whenever your radius is 1 to the point of tendency, then tangent ME will be perpendicular to the radius EQ. If ME is perpendicular to EQ, it means that this angle equals to 90 degrees according to rule 1. And finally, we join points S and F together by straight line. SF is the radius of this circle is equal to R. And according to rule 1, because of the fact that the radius SF is 1 to point F, that is the point of tendency of tangent MF with this circle. And now your radius is 1 to the point of tendency, then tangent MF will be perpendicular to the radius FS. If MF is perpendicular to FS, it means this angle equals to 90 degrees according to rule 1. So, in the next step, we join points M and P together by straight line. So, joining points M and P, we can do the right triangle MPD. Likewise, we join points M and Q together by straight line. So here we created the right triangle, triangle MQE, and finally we join points M and S together by straight line. So here we created the right triangle. Triangle MSF. So in the next step, we'll implement the Pythagoras theorem on those three right triangles. So first of all, we'll implement the Pythagoras theorem on this right triangle, triangle MPD. This right triangle, triangle MPD, according to the Pythagoras theorem, MP squared, that is the square of the hypotenuse, is equal to PD squared plus MD squared. So in total, according to equation 1, we can find out that in the right triangle, triangle MPD, MP squared equals to PD squared plus MD squared. MP is the missing hypotenuse of unity cities, so it is MP squared, that is equal to PD squared. PD is out, therefore PD squared is R squared plus MD squared. MD is 5, therefore MD squared is 5 squared. So in total, according to equation 1, we should find out that MP squared equals to R squared plus 25. We repeat on the same process in this right triangle, triangle MQE. In the right triangle MQE, according to the Pythagoras theorem, MQ squared, that is the square of the hypotenuse, is equal to QE squared plus ME squared. It again, according to the Pythagoras theorem, in the right triangle, triangle MQE, MQ squared equals to QE squared plus ME squared. MQ is the missing hypotenuse, so we know it as it is. So it is MQ squared. It is equal to QE squared. QE is out, therefore QE squared is R squared plus ME squared. ME is 7, therefore ME squared is 7 squared, it is 49. So in total, according to equation 2, we can find out that MQ squared equals to R squared plus 49. We implement the Pythagoras theorem on this right triangle, triangle MFS. According to the Pythagoras theorem, in the right triangle MFS, MS squared, that is the square of the hypotenuse, is equal to SF squared plus MF squared. But again, according to the Pythagoras theorem, in the right triangle MSF, MS squared equals to SF squared plus MF squared. MS is the missing hypotenuse, so we know it as it is. So MS squared equals to SF squared. SF is R, therefore SF squared is R squared plus MF squared. mf is x, therefore mf squared is x squared. So in total, according to equation 3, we should find out that ms squared equals to r squared plus x squared. Repeat again, according to equation 3, we should find out that ms squared equals to r squared plus x squared. In the next step, we join points P and A together by straight line. So PA is of course the radius of this circle is equal to R. So according to rule 1, because of the fact that the radius PA is 1 to point A, this is the point of tendency of this big tangent with this circle, and whenever your radius is 1 to the point of tendency, then the big tangent will be perpendicular to the radius AP. That is to say, this angle equals to 90 degrees. Likewise, we join points Q and B together by straight line. QB is the radius of this circle that is equal to R, and according to rule 1, this angle equals to 90 degrees, and this angle also equals to 90 degrees. And finally, we join points S and C together by straight line. SC is the radius of this circle is equal to R, and according to rule 1, this angle equals to 90 degrees, and this angle also equals to 90 degrees. And because of the fact that those 3 points P, Q, and S, they are located in the same distance from the straight line ABC. This is the straight line ABC. Point P, the distance of point P from the straight line ABC is R. The distance of this point Q from the straight line ABC is also R. And the distance of this point S from the straight line ABC is also R. That is the radius of this circle. So the 3 points P, Q, and S are located in the same distance from the straight line ABC, and therefore the 3 points P, Q, and S must be located on the same straight line. Again, the straight line P, Q, and S must be located on the same straight line. Moreover, because of the fact that the distance of these 3 points P, Q, and S from the straight line ABC is the same distance, that is R, the straight line PQS must be parallel to the straight line ABC. Again, because of the fact that the distance of the 3 points P, Q, and S from the straight line ABC is equal, and it is equals to R, therefore the straight line PQS must be parallel to the straight line ABC. Okay, so here we can implement rule 17. Because of the fact that the straight line PQS is parallel to the straight line ABC, we can implement here rule 17. So I'm clicking quickly on rule 17. According to rule 17, the sum of one-sided interior angles between 2 parallel lines is equal to 180 degrees. So those are angle 2 and 1, and they defined as one-sided interior angles. They are one-sided because they are both located on the right side of the red line, C. And they are interior angles because of the fact that they are located between the parallel lines A and B. So in total, they are one-sided interior angles. And according to this rule 17, the sum of 2 one-sided interior angles that are located between 2 parallel lines is equal to 180 degrees. So that is to say, angle 2 plus angle 1 equals to 180 degrees. Likewise, those 2 angles, alpha and beta, are also defined as one-sided interior angles, and according to this rule 17, the sum of those 2 angles is equal to 180 degrees. That is to say, alpha plus beta equals to 180 degrees. So we can actually implement rule 17 in our drawing. Why? Because of the fact that those two angles, they are defined as one-sided interior angles, and according to Rule 17, the sum of those two angles must be equal to 180 degrees. So 90 degrees plus the missing angle, in total must be equal to 180 degrees. And therefore this missing angle must be equal to 90 degrees in its size. Likewise, according to the sum rule, Rule 17, those two angles, they are both defined as one-sided interior angles, and according to Rule 17, the sum of two one-sided interior angles is equal to 180 degrees. So 90 degrees plus this missing angle, in total it must be equal to 180 degrees. Therefore the missing angle must be equal to 90 degrees in its size according to Rule 17. Likewise, the sum of those two angles that are defined as one-sided interior angles, in total it must be equal to 180 degrees. So 90 degrees plus the missing angle, in total it must be equal to 180 degrees. Therefore the missing angle must be equal to 90 degrees in its size. And finally, those two angles also defined as one-sided interior angles, and are located between the parallel lines PQS and ABC, and therefore the sum of those two angles must be equal to 180 degrees. So this angle is a right angle plus this missing angle, in total it must be equal to 180 degrees. Therefore this missing angle must be equal to 90 degrees in its size. So in this quadrangle QSCB, we have four right angles, and according to Rule 5, any quadrangle that has four right angles must be at its left angle in front of square. So relate to this quadrangle QBCS is a left angle. This is a left angle according to Rule 5. But we also know that the opposite sides of a left angle are equal to each other. So a left angle QSCB, side BC must be equal to the opposite side QS. But BC is 3, therefore QS must be also equal to 3 units in its length. Likewise, inside this quadrangle PQBA, we have four right angles. And according to Rule 5, any quadrangle that has four right angles must be at its left angle in front of square. So we relate to this quadrangle as a left angle. But we also know that the opposite sides of a left angle are equal to each other. So a left angle PQBA, side AB must be equal to the opposite side PQ, but AB is 3, therefore PQ must be also equal to 3 units in its length. In the next step, we focus on the big triangle MPS. So I'll copy the big triangle MPS in a new page, and we'll analyze this big triangle MPS. This is point Q. We just write down formula that PQ equals to 3 and QS also equals to 3 units in its length. So this is triangle NPS, the deformity from the original domain. So from the vertex M, we will draw a straight line to the midpoint of side PS, that is point Q. Actually, line segment MQ is defined as a median of this triangle MSP, well, because of the fact that it starts from the vertex M and ends at point Q, that is the midpoint of side PS. That is to say, the median PS bisects side PS. That is to say, it divides side PS into two halves. Each half equals to 3. PQ equals to 3 and QS also equals to 3. Therefore, MQ is defined as a median of triangle MPS. Repeat again. A median of a triangle starts from a vertex and ends at the opposite side of this vertex M, that is side PS, and the median MQ bisects the opposite side PS. That is to say, it divides side PS into two halves. Each half equals to 3 units. PQ equals to 3 and QS also equals to 3. So, we want to find out the length of the median MQ. Actually, we have a new formula for the length of the median MQ. So the length of a median in a triangle. What is the length of a median in a triangle? A median to a triangle is a line segment from a vertex to the midpoint of the opposite side. This is triangle ABC. The length of side AB is B units, side AC equals to C units in its length, and side BC equals to A units in its length. AD is the median of this triangle ABC. The median AD starts from the vertex A and ends at the opposite side of the vertex A, that is side BC. The median AD bisects the opposite side BC. That is to say, it divides the opposite side BC into two halves. Each half equals to, the first half is BD, and it of course equals to the second half DC. So the median AD bisects the opposite side BC. So what is the length of the median AD? Again, AB equals to B units in its length, AC equals to C units in its length, and BC equals to A units in its length. And the length of the median AD is equal to the square root of 2b squared plus 2c squared minus a squared over 2. Again, the length of this median AD is equal to the square root of 2b squared plus 2c squared minus a squared over 2. So we can actually implement the formula for the median in order to find out, in our drawing, in order to find out the length of the median MQ. According to the new formula, the length of the median MQ will be equal to MQ equals to 1 over 2 times the square root of MP square, 2 times MP square plus 2 times MS square minus PS square. Again, according to the new formula, the length of the median MQ is equal to 1 over 2 times the square root of MP square plus 2 times ms squared minus ps squared. So mq equals to mq equals to 1 over 2 times square root of 2mp squared plus 2ms squared minus ps squared. So here we multiply this equation by 2, and finally we get that 2 times mq equals to the square root of 2mp squared plus 2ms squared minus ps squared. So here we'll square both sides of this equation, and we get that 2 times mq squared is 2 squared, that is 4, times mq squared, and it is equals to, here, when we square the root, it will be cancelled, and we're left only with 2mp squared, because the square cancels the root, and we're left only with 2mp squared plus 2ms squared minus ps squared. So according to the formula for the length of a median, we found out that four times mq squared equals to 2 times mp squared plus 2 times ms squared minus ps squared. According to equation 1, mp squared equals to r squared plus 25. Therefore, we substitute mp squared here by r squared plus 25. It will be equal to 2 times mp squared is r squared plus 25 plus 2 times ms squared. ms squared is r squared plus x squared. So it will be plus 2 times ms squared. ms squared is r squared plus x squared minus ps squared. ps in total equals to 3 plus 3, that is 6. Therefore ps squared is 6 squared, that is 36. So in total, in this end of the equation, we have 2 times r squared plus 25 plus 2 times r squared plus x squared minus 36. And this end of the equation, we have 4 times mq squared. mq, according to equation 2, mq squared equals to r squared plus 49. Therefore, we substitute mq squared here by r squared plus 49. In total, we found out that 4 times r squared plus 49 equals to 2 times r squared plus 25 plus 2 times r squared plus x squared minus 36. So here we'll open the brackets on both sides of this equation and get that 4 times r squared plus 4 times 49, it is 196, equals to 2 times r squared plus 2 times 25 is 50 plus 2 times r squared plus 2x squared minus 36. So in this side of the equation we have 4r squared, in the other side of the equation we have 2r squared plus 2r squared, that is 4r squared. So 4r squared get cancelled. So in this side of the equation we left only with 196. This is equals to, here we have 50 minus 36 is 14 plus 2x squared. Here we subtract 14 from this equation and we get that 196 plus 14 is 182. So 182 equals to 2x squared. Here we divide this equation by 2, and we get that 182 over 2 is 91, so 91 equals to x squared. Here we take a root out of this equation, and finally we get that x equals to either square root of 91, in terms of numbers it is equal to 9.54 units. So check. 9.54 units, okay. The square root of 91 is 9.54 units. So in total, we should find out that the length of this tangent MF, that is tangent to this circle, the length of tangent MF that is equal to x is equal to either square root of 91 units. In terms of numbers, it is equal to 9.54 units. Actually, it makes sense because the length of tangent MD is 5, the length of tangent MF is, the length of tangent ME, this tangent is 7, and it is very clear that tangent MF is longer than tangent ME, that is 7. Therefore, tangent MF must be a little bit longer than ME, that is 7. So M equals to 9.54 units in its length. So finished with the first question. In the next step, I present to you the second question in this lecture. So our mission in the second question is to find out the length of this tangent AP that equals to x. Our mission is to find out the value of x. So in the drawing we have a quarter circle. Inside this quarter circle we have this circle, and again we have here tangent AP that is tangent to this, we have tangent AP that is tangent to this small circle at point P, and according to what is given in the question, the length of tangent AP is x, and our mission is to find out the value of x. Okay, so first of all, we define the center of this small circle. This point is point C. We define the radius of this small circle as A. We join point C and P together by a straight line. CP is of course the radius of this circle, that is A. So here we can implement rule 1 because of the fact that the radius CP is drawn to point P, that is the point of tendency of tangent AP with this small circle, and whenever you have radius that is drawn to the point of tendency, then tangent AP will be perpendicular to the radius PC. If AP is perpendicular to PC, it means that this angle equals to 90 degrees according to rule 1. In the next step, we join points A and C together by a straight line. By joining points A and C, we created the right triangle, triangle APC. So we copy the right triangle APC in a new page, and we'll implement the Pythagoras theorem on this right triangle APC. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Here by PT is a progression from Pythagoras theorem. actually. This is the right triangle APC, this is the clone from the original drawing. This right triangle APC, AC squared, that is the square of the hypotenuse, equals to CP squared plus AP squared. So I'll write it down. AC squared, that is the square of the hypotenuse, is equal to AP squared plus PC squared. The hypotenuse AC is the missing side, so relativity, so it is AC squared equals to AP squared. AP is x, therefore AP is x, therefore AP squared is x squared plus PC squared. PC is a, therefore PC squared is a squared. So in total, according to equation 1, actually found out that AC squared equals to x squared plus a squared. In the next step, we define the radius of the big quarter circle as B. So OB is the radius, is equals to B. OA is also the radius of this quarter circle, is equals to B units in its length according to our definition. So we define the touching point of the small circle with this quarter circle. This point is point K. We join point C and Q together by a straight line. CQ is the radius of this small circle, that is equal to A. Again, the radius CQ is drawn to point Q, that is the point of tendency obtained OB with this small circle. And whenever your radius is drawn to the point of tendency, then tangent OB will be perpendicular to the radius QC. If OB is perpendicular to QC, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. Because of the fact that we have an internal arch between the small circle and the big quarter circle, whenever you have an internal arch between two circles or semicircles, you can implement rule 9. So I'll take rule 9. According to rule 9, if two circles touch each other internally, then the straight line that connects their centers together passes for their touching points. So in the drawing we have this big circle, this small semicircle, this small circle. The center of this big circle is at point O, the center of this small circle is at point M. And the straight line that connects their centers together is of course the straight line OM. And according to this rule 9, the straight line OM must pass for their touching point, that is point P. OMP is one straight line. Again, the straight line OM must pass for point P, that is their touching point, or OMP is one straight line. So you can actually implement rule 9 in our drawing, or in our drawing we have internal arch between this small circle and the big quarter circle, that is to say they touch each other internally at point K. The center of this small circle is at point C. The center of this big quarter circle is at point O. And the straight line that connects their centers together is of course the straight line OC. And according to rule 9, the straight line OC must pass for point K, that is their touching point. Again, according to rule 9, the straight line OC must pass for their touching point, that is point K. Or OCK is one straight line. Again, according to rule 9 OCK is one straight line. So we join points O and C together by straight line, and the straight line OC must pass for point K, that is the attaching point. So the straight line OC indeed passes for point K, that is the attaching point. What is the definition of line segment CK? Point C is the center of the small circle, point K is the point on the small circle itself. Therefore CK is the radius of this small circle, that is A units, according to our definition. So CK equals to A. Point O is the center of the quarter circle, point K is the point of the quarter circle itself, so this is exactly the definition of a radius. Therefore OK is the radius of the quarter circle, that is equals to units in its length according to our definition. What is the length of line segment OC? From the drawing it is very easy to see that OC in total equals to OK minus CK. Again, OK minus CK equals to OC. So I write it down. OC equals to OK minus CK. So total OC equals to OK. OK is B, it is the radius of the quarter circle, minus CK. CK is 8, is the radius of the small circle. So in total OC equals to B minus A units in its length. OC equals to B minus A units. So this is 9/7 OC, outside OC, that is equals to B minus A units in its length. Actually, it is given us in the question that OQ equals to 5 units in its length. Okay. So, in the next step, we'll copy the right triangle OCQ in the new page, and we will implement the Pythagoras theorem on this right triangle OCQ. Here by PT is the abbreviation for Pythagoras theorem. Again, the hypotenuse also equals to B minus A units in its length. Side OQ equals to 5 units in its length. And CQ is the radius of this small circle, this equals to A units in its length according to our definition. So, actually, this is the right triangle OCQ. This is the right triangle OCQ that I copied from the original drawing. According to the Pythagoras theorem, in this right triangle OCQ, OC square equals to CQ square plus QO square. Again, OC square equals to CQ square plus QO square. So I write it down, this will be equation 2. Only to equation 2. OC square equals to CQ square plus QO square. OC is B minus A, therefore OC square is B minus A square, and it is equals to CQ square. CQ is A, therefore CQ square is A square, plus QO square. QO is 5, therefore QO square is 5 square. That is 25. So in total, according to equation 2, we shall find out that B minus A square equals to A square plus 25. We will open the brackets on this side of this equation 2, and we get that B minus A square equals to B square plus A square minus 2 times A times B, and it is equals to A square plus 25. Here we have A square on both sides of the equation, so A square will get cancelled. After we cancel A square, in this side of the equation 2 we have here B square minus 2AB. On the other side of this equation 2 we have 25. So in total, according to equation 2, we should find out that B square minus 2AB equals to 25. So in the next step, we will do a construction. That is to say, from this point C, we will draw perpendicular on AO. Again, from point C, we will draw perpendicular on AO. So actually, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point C and AO. This point is point N. Actually, by doing this construction, we get the quadrangle NCQO. Inside this quadrangle NCQO, we have 1, 2, 3 vertices. The sum of 3 vertices is 270 degrees. So 270 degrees plus the size of this fourth missing angle, in total they must be equal to 360 degrees according to the rule that states that the sum of the angles in any quadrangle is equal to 360 degrees. Therefore this fourth missing angle must be equal to 90 degrees in its size. So inside quadrangle NCQO we have 4 angles. And according to rule 5, any quadrangle that has 4 angles must be a rectangle if not a square. So we relate to this quadrangle NCQO as a rectangle because it has 4 angles. But we also know that double sides of a rectangle are equal to each other. So in rectangle NCQO, side NC must be equal to double side QO, but QO is 5. Therefore NC must be also equal to 5 units in its length. Likewise, according to the sum rule, in the sum rectangle NCQO, side CQ must be equal to double side NO, but CQ is 8, therefore NO must be also equal to 1 unit in its length. What is the length of line 7 AN? And AN equals to AO minus NO. Again, AN equals to AO minus NO. So I'll write it down. AN equals to AO minus NO. So AN in total equals to AO, that is B, minus NO, that is A. So in total AN equals to B minus A units in its length. AN equals to B minus A units in its length. So in the next step, I'll copy the right triangle ACN in your page and we'll implement the Pythagoras theorem on this right triangle, triangle ACN. Here by PT is a version for Pythagoras theorem. So actually, this is the right triangle ACN, is the chord from the original domain according to the Pythagoras theorem. In this right triangle ACN, AC squared equals to AN squared plus NC squared. So I write it down. AC squared, that is the square of the hypotenuse, equals to AN squared plus NC squared. AC squared equals to AN squared. AN is B minus A, therefore AN squared is B minus A squared plus NC squared. NC is 5, therefore NC squared is 5 squared, this is 25. So in total, according to equation 3, we have found out that AC squared equals to B minus A squared plus 25. According to equation 1, AC squared equals to X squared plus A squared. Therefore, we substitute AC squared in this equation, equation 3, by X squared plus A squared from equation 1. So according to equation 3, AC squared, so AC squared is X squared plus A squared, that is equal to B minus A squared. B minus A squared equals to B squared plus A squared minus 2 times A times B plus 25. So here we have A squared on both sides of the equation, so A squared will get cancelled. After we cancel A squared, in the side of this equation, equation 3, we left only with X squared. On the other side of this equation 3, we have B squared minus 2 times AB plus 25. But again, according to equation 3, we found out that X squared equals to B squared minus 2 times AB plus 25. But according to equation 2, we have only found out that B squared minus 2AB equals to 25. Therefore, we substitute B squared minus 2AB here in this equation 3 by 25. And we get that X squared in total equals to B squared plus 2AB is 25 according to equation 2 plus 25. So in total X squared equals to 25 plus 25, that is 50. Here we take a water out of this equation and we get that X equals to the square root of 50. 50 is 2 times 25, and the square root of 25 is 5. So in total, this expression equals to 5 times square root of 2. In terms of numbers, it is equal to 7.071 units. So we found out that the length of this tangent AP is equal to X is equal to either 5 times square root of 2 units. In terms of numbers, the length of this tangent AP is equal to X is equal to 7.071 units in its length. Finish with the second question. In the next step, I'll summarize the lecture. We'll start with the first question, of course. Our mission in the first question is to find out the length of this tangent MF that is equal to X. So in the domain we have 3 circles and we have tangent, the big tangent extended to this circle at point A, extended to this circle at point B, and extended to this circle at point C. In addition, we know that AB equals to 3 units in its length, BC equals to 3 units in its length. In addition, we have the common external point, point M. From the common external point, point M, we have tangent MD that is extended to this circle at point D, and the length of tangent MD is 5. In addition, we have also tangent ME that is extended to this circle at point E, and the length of this tangent ME is 7. And finally, we have also tangent MF that is extended to this circle at point F. And according to what is given as the question, MF equals to X, and our mission is to find out the length of tangent MF that is equals to X, so to find out the value of X. So, first of all, we define the center of this circle as P, the center of this circle as Q, and the center of this circle as point S. We join points P and A together by certain PA is the radius of this small circle is equals to, we define the radius of this small circle as R. And according to Rule 1, because of the fact that the radius PA is 1 to point 8, it is the point of tendency of the big tangent with this circle, this angle must be equal to 90 degrees. Likewise, we join points O and B together by certain or points Q and B together by certain QB is the radius of this circle that is equals to R, and because of the fact that the radius QB is going to point B, then this point must be, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to Rule 1. And finally, we join points S and C together by certain S is the radius of this circle that is equals to R, because those three circles are identical. And according to Rule 1, because of the fact that the radius SC is known to point C, that is the point of tendency of the matrix tangent with points with this circle. Therefore, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to the sum rule 1. Okay, so in the next step, we joined points N, M and P together by certain. Again, PQ or PD, we join points P and D together by certain. PD is the radius of this circle that is R, and according to Rule 1, this angle equals to 90 degrees. By doing this construction, we created the right triangle MPD. Likewise, we join points M and Q together by certain. We join points Q and E together by certain. Q is the radius of this circle that is equals to R, and according to Rule 1, this angle equals to 90 degrees. Likewise, we join points M and S together by certain, and we join points S and F together by certain. SF is the radius of this circle that is equal to R, and according to Rule 1, this angle equals to 90 degrees. In the next step, we implemented the Pythagoras theorem on these three right triangles. According to the Pythagoras theorem, in this right triangle MPD, MP square equals to 5 square plus R square. MP square equals to 5 square, this is 25, plus R square. Then we implemented the Pythagoras theorem on this right triangle MQE. In this right triangle MQE, according to the Pythagoras theorem, MQ square equals to R square plus 7 square. Again, MQ square equals to R square plus 7 square, this is 49. So in total, according to equation 2, MQ square equals to R square plus 49. And finally, we implemented the Pythagoras theorem on this right triangle MSF. In this right triangle MSF, MS square equals to SF square plus FM square. Again, MS square equals to SF square plus MF square. SM is the missing side, so we leave this it is. SF is the radius of this circle that is R, so the SF square is R square plus MF square. MF equals to X. X is the value that we are looking for in this question. So MF square equals to X square. So in total, according to question 3, MS square equals to R square plus X square. So here because of the fact that the 3 points P, Q, and S are all at the same distance from the straight line ABC, therefore they themselves must be located on one straight line. Again, because of the fact that the 3 points P, Q, and S are at the same distance from the straight line ABC, those 3 points P, Q, and S must be located on one straight line. That is to say, PQS is one straight line, and for the same reason, the straight line PQS must be parallel to the straight line ABC. Again, the straight line PQS must be parallel to the straight line ABC. And here we can implement rule 17. So I'll repeat quickly rule 17. According to rule 17, the sum of one-sided interior angles between two parallel lines is equal to 180 degrees. Those two angles are defined as one-sided interior angles, and therefore, according to this rule, rule 17, the sum of those two angles is equal to 180 degrees. That is to say, 2 plus 1, angle 2 plus angle 1 equals to 180 degrees. Likewise, those two angles are also defined as one-sided interior angles, and according to this rule, rule 17, the sum of those two angles is equal to 180 degrees. That is to say, alpha plus beta equals to 180 degrees. We can implement rule 17 in our drawing. Because in our drawing, we have those two angles that are defined as one-sided interior angles. And according to rule 17, the sum of those two angles is equal to 180 degrees. So 90 degrees plus the missing angle in total must be equal to 180 degrees. Therefore, the missing angle must be equal to 90 degrees in its size. Likewise, the sum of those two angles must be also equal to 180 degrees, according to rule 17, because of the fact that they are defined as one-sided interior angles. So this is the right angle according to rule 1. Plus this missing angle, in total it must be equal to 180 degrees. Therefore, the missing angle must be equal to 90 degrees in its size. Likewise, according to the sum rule, the sum of those two angles must be equal to 90 degrees. But this angle equals to 90 degrees according to rule 1. So 90 degrees plus the missing angle, in total it must be equal to 180 degrees. Therefore, this missing angle must be equal to 90 degrees in its size. And finally, those two angles are also defined as one-sided interior angles, and according to rule 17, the sum of those two angles must be equal to 180 degrees. This angle equals to 90 degrees according to rule 1. So 90 degrees plus the missing angle, in total must be equal to 180 degrees. Therefore, this missing angle must be equal to 90 degrees in its size. So inside this quadrangle PQBA, we have right angles. Therefore, quadrangle PQBS is a rectangle. But we know that the opposite sides of rectangle are equal to each other. So rectangle PQBA, side PQ must be equal to the opposite side VA. But VA is 3, therefore PQ must be also equal to 3 units in its length. Likewise, in this quadrangle QSBC, we have 4 right angles, and according to rule 5, this quadrangle with 4 right angles is a rectangle. But we also know that the opposite sides of rectangle are equal to each other. So in rectangle QSCB, side QS must be equal to the opposite side CB. But CB is 3, therefore QS must be also equal to 3 units in its length. In the next step, I call it the right big triangle, triangle AMS. And in fact, you analyze this triangle AMS. Actually, it is triangle MPS. So this is triangle MPS that I call it from the original drawing. We just write down found that PQ equals to 3 units in its length, and QS also equals to 3 units in its length. MP and MQ, the red line MQ, is defined as a median of this triangle, triangle MPS. The median of any triangle starts from the vertex and ends at the opposite side, at the midpoint of the opposite side. The opposite side of this vertex M is PS, and the midpoint is Q. The median MQ bisects side PS, that is to say, divides it into 2 halves. The first half is PQ, and it is, of course, equals to the second half, that is QS. Each half is equal to 3 units in its length. So what is the length of the median MQ? We have a special formula for the length of the median MQ. Actually, according to the special formula, this is triangle ABC. Side AB equals to B units in its length, side AC equals to C units in its length. This is side BC, this is equals to A units in its length. AD is the median to side BC. That is to say, it divides side BC into two halves. The first half is BD, and it is of course equals to the second half DC. So what is the length of the median AD? According to the formula, the length of the median AD is equals to 1 over 2 times the square root of 2b squared plus 2c squared minus a squared. Again, AD equals to the square root of 2b squared plus 2c squared minus a squared over 2. So can actually implement the new rule now as always in order to find out the median MQ. According to the new formula, MQ must be equal to 1 over 2 times the square root of 2mp squared plus 2ms squared minus ps squared. Again, the length of the median MQ is equal to 1 over 2 times the square root of 2mp squared plus 2ms squared over ps squared. So here we multiply this equation by 2 and found out that 2mq equals to the square root of 2mp squared plus 2ms squared minus ps squared. Here we squared both sides of this equation. So 2m squared is 2 squared, that is 4 times mq squared. Again, 2 times mq squared is 2 squared, that is 4 times mq squared. And here we squared this, when you squared the root, the square cancels the root, and we left only with 2mp squared plus 2ms squared minus ps squared. So actually found out that according to this equation for the median of the median MQ, the length of the median MQ, we get that 4 times MQ square equals to 2 times MP square plus 2 times MS square minus PS square. But according to equation, according to equation 2, MQ square equals to R square plus 49. So we substitute MQ square by R square plus 49, and we have here 2MP square. According to equation 1, MP square equals to R square plus 25. Therefore, we substitute MP square here by R square plus 25, and we have here 2MS square. MS square is R square plus X square. So we substitute MS square here by R square plus X square, and we have minus PS square. PS in total is 3 plus 3, that is 6. Therefore, PS square is 6 squared, that is 36. So PS square in total is 36. PS square is 36. Here we open the brackets and finally found out that 4R square, 4 times 49 is 196, and here we have 2R square plus 2 times 25, that is 50. Here we have 2R square plus 2X square minus 36. In this side of the equation we have 4R square, and the other side of the equation we have 2R square plus 2R square, that is 4R square. So 4R square will get cancelled. So in this side of the equation, after we cancelled 4R square, we left only with 196. On the other side of the equation we have 50 minus 36 is 14. So in total, this side of the equation we have 14 plus 2x squared. So in total, we found out that 196 equals to 14 plus 2x squared. Here we subtracted 14 from this equation, and finally found out that 196 minus 14 is 182. So 182 equals to 2x squared. Here we divided this equation by 2, and finally found out that x squared equals to 182 over 2 is 91. So x squared equals to 91. We took out of this equation, and finally found out that x equals to the square root of 91 the square root of 91 is 9.54 units. So if you found out that the length of this tangent MF is equal to x, it is equal to either the square root of 91 units, or in terms of numbers, the length of tangent MF is equal to x is equal to 9.54 units. So we finish the first question. In the next step, I present to the second question. Our mission in the second question is to find out the length of this tangent AP is equal to x according to what is given as the question. So in the drawing we have a small circle. Inside this quarter circle AOB. We know that line segment OQ equals to 5 units in its length. We also know that actually we defined the center of this circle. This point is point C, and we define the radius of this small circle as A. So CQ is the radius of this small circle, that is equals to A according to our definition. The radius CQ is 1 to point Q, that is the point of tendency of tangent OB with this small circle. And whenever your radius is 1 to the point of tendency, then tangent OB will be perpendicular to the radius QC. If OB is perpendicular to QC, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees, according to rule 1. In the next step, we join points A and C together by straight line, and we join points C and P together by straight line. CP is of course the radius of this small circle, that is equals to A, and because of the fact that the radius CP is 1 to point P, that is the point of tendency of tangent AP with this small circle, whenever you have a radius that is 1 to the point of tendency, then tangent AP will be perpendicular to the radius PC. If AP is perpendicular to PC, it means that this angle goes to 90 degrees according to rule 1. In the next step, I call it the right triangle APC in your page, and implement the Pythagorean theorem on this right triangle, triangle APC. This is the right triangle APC, that I call it on the original domain. In this right triangle APC, according to the Pythagorean theorem, AC squared equals to AP squared plus PC squared. So AC squared equals to AP squared, AP is x, therefore AP squared is x squared, plus PC squared. PC is a, therefore PC squared is a squared. So in total, AC squared equals to x squared plus a squared, according to equation 1. In the next step, we actually, because of the fact that we have an internal match between this small circle and this big quarter circle, that is to say they touch each other at point Q. Whenever you have an internal match between two circles, you can implement all 9. So I print quickly on all 9. According to rule 9, if two circles touch each other internally, then the straight line that connects the centers together passes for their touching point. So in the domain you have two circles, the center of this big circle is 0.0, the center of this small circle is 0.m. The straight line that connects the centers together is the straight line OM. And according to this rule 9, the straight line OM must pass for their touching point, that is point P. Again, the straight line OM must pass for point P, that is their touching point. Or OMP is one straight line. Again, OMP is one straight line according to this rule 9. So we can actually implement rule 9 in our drawing. When we put in our drawing, we have an internal match between this small circle and this big quarter circle. That is to say, they touch each other internally at point K. Therefore, according to rule 9, the center of this quarter circle is at point O. The center of this small circle is at point C. And the straight line that connects the centers together is the straight line OC. This straight line OC must pass for the touching point, that is point K. The straight line OC must pass for point K, that is the touching point, or OCK is one straight line. Again, OCK is one straight line. CK is the radius of this small circle, that is A. OK, starts from point O, that is the center of this quarter circle, and K is the point of the quarter circle itself. So this is exactly the definition of a radius. Therefore, OK is the radius of this big quarter circle that is equals to units in its length according to our definition. So CK equals to A and OK equals to B. So the length of this line segment OC is equals to OK minus CK again. OC equals to OK minus CK. So OC equals to OK, that is B, minus CK, that is A. So in total, OC equals to B minus A units in its length. In the next step, I copied the right triangle COQ in a new page and implemented the Pythagoras theorem on the right triangle OCQ. This is the right triangle OCQ that I copied from the original drawing. According to the Pythagoras theorem, this right triangle OCQ, OC squared equals to CQ squared plus QO squared. OC is B minus A, therefore OC squared is B minus A squared, and it is equals to Q squared. CQ is A, therefore CQ squared is A squared, plus OQ squared. OQ is 5, therefore OQ squared is 5 squared. So in total, according to equation 2, we shall find out that B minus A squared equals to A squared plus 25. We open the brackets in this, on the side of the equation 2, and finally found out that B minus A squared equals to B squared plus A squared minus 2 times AB, and it is equal to A squared plus 25. We have A squared on both sides of the equation, so A squared will get cancelled. After we cancel A squared, in this side of the equation we left with B squared minus 2AB, and the other side of the equation we left with 25. So in total, according to equation 2, we should find out that B squared minus 2AB equals to 25. In the next step, we did a construction, that is to say, from this point C, we do a perpendicular on AO. Again, from point C, we do a perpendicular on AO. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point C and AO. This point is point N. By doing this construction, we get the quadrilateral NOQC. Inside this quadrilateral NOQC, we have 1, 2, 3 angles. The sum of 3 angles is 270 degrees. So 270 degrees plus the size of this 4 pieces again, in total must be equal to 360 degrees according to the rule that states that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, this 4 pieces again must be equal to 90 degrees in its size. So, quadrilateral NCQO have 4 angles, and therefore it is a rectangle. But we also know that the opposite sides of a rectangle are equal to each other. So in that again, NCQO side, NC must be equal to the opposite side OQ. But OQ is 5, therefore NC must be also equal to 5 units in its length. Likewise, according to the sum rule, in the sum of NCQO, side QO must be equal to the opposite side NO. But NO is A, therefore, but CQ is A, therefore NO must be also equal to A units in its length. What is the length of AN? AN equals to AO minus NO. Again, AN equals to AO minus NO. So AN equals to AO, that is B, it is the radius of the quarter circle, minus ON. ON is A. So in total, AN equals to B minus A units in its length. Again, AN equals to B minus A units in its length. In the next step, I copied the right triangle ANC in a new page and implemented the Pythagoras theorem. This right triangle ANC. This right triangle ANC, AN equals to B minus A. NC equals to 5 units in its length. AC is the missing side. So this is the right triangle ANC that I copied from the original drawing. In this right triangle ANC, AC square equals to AN square plus NC square. AC is the missing side, so we leave it as it is. So it is AC square equals to AN square. AN is B minus A, therefore AN square is B minus A square plus NC square. NC is 5, therefore NC square is 5 squared, that is 25. So in total, according to equation 3, we should find out that AC square equals to B minus A square plus 25. According to equation 1, AC square equals to X square plus A square. Therefore, we can substitute A square by X square plus A square. So AC square equals to X square plus A square according to equation 1. And B minus A square equals to B square plus A square minus 2 times AB plus 25. we have a square on both sides of the equation, so a square will get cancelled. After we cancel a square, in the side of this equation, we left only with x square. In the other side of the equation, we have b square minus 2ab plus 25. So repeat again. In this side of the equation, we left with x square. In the other side of the equation, we have b square minus 2ab plus 25. But according to equation 2, b square minus 2ab equals to 25. Therefore, we can substitute b square minus 2ab here by 25. We did it, and we have found out that x squared equals to b squared minus 2ab is 25 plus 25. So in total, x squared equals to 25 plus 25, this is 50. So x squared equals to 50. We took out of this equation and finally found out that x equals to the square root of 50. 50 is 2 times 25. The square root of 25 is 5. So in total, this expression equals to 5 times square root of 2 units in its length. 5 times square root of 2 is 7.071 units. So in total, we have found out that the length of this tangent AP is equals to x. It is equal to either 5 times square root of 2 units in its length, or in terms of numbers, the length of tangent AP is equal to x is equal to 7.071 units in its length. Okay, thank you very much.